please support me through PayPal to devinwindham@gmail.com. devinwindham@gmail.com is one word, all lowercase. I also do tutoring both online and in person. I'm based in Fairfax, Virginia. If you're interested in tutoring, you can reach me at that same email. Please subscribe to my channel. All right, I want to talk about the fact that I think understanding is more important than memorizing in math. I started this YouTube channel recently. A lot of it's devoted to that topic, that understanding is more important than memorizing in math. And along those lines, a lot of my YouTube videos are proofs. That's what I mean by understanding. Let's take the Pythagorean Theorem. The Pythagorean Theorem says that in any right triangle, the square of the hypotenuse is equal to the sum of the squares of the legs. Well, I mean, you can understand what that means if you know the definition of the terms involved. If you know the definition of a right triangle, if you know the definition of hypotenuse, if you know the definition of a leg, and if you know the definition of squaring, and you know the definition of equal to, and you know the definition of addition, etc. But that's one type of understanding. The type of understanding I'm referring to is deep understanding. It's understanding, why is that true? Why is it true that, to abbreviate, why is it true that c squared equals a squared plus b squared? Well, to understand why that's true, you basically convince yourself that it's true, and the typical way that mathematicians do that is with what's called a proof. So, I did a YouTube video where I proved that, and why do I think that type of understanding is so important in math? Well, for one thing, I think you get good at what you enjoy. My brother had a book on his coffee table that said, do what you love, the money will follow. And I agree with that. I think the spirit behind that book is that if you do what you love, you'll spend energy and time on it, so you'll get good at it. So, you'll get rich doing it or have success. And I think understanding math helps you enjoy it. It helps me enjoy it because it gives me a sense of fulfillment. I feel that I own the parts of math and physics that I've proved to myself, and that I don't really own. It's sort of foreign or mysterious to me, the parts that I haven't really proved. I can give some examples of that. Like, there are two definitions of the cross product. The cross product of two vectors is equal to the magnitude. It's a vector whose magnitude is equal to the product of the magnitudes of the two vectors and the product of the sine of the angle between them. I mean, one issue is right there. How do you determine the angle between them? I mean, there are at least two ways you can go. And then the direction of the answer vector is determined by the so-called right-hand rule. Well, the other definition of the cross product involves these unit vectors called I, j, and k, and I guess you just multiply them using the distributive law or something. I mean, first of all, how is the distributive law just automatically valid for the cross product of vectors? And second of all, why are those two definitions equivalent? So that's something I haven't proved, and that bugs me because things like that are used to send the spacecraft Perseverance to Mars. I mean, I use stuff like that in a proof. There was a proof I saw that the orbits of planets are ellipses, and that's what we use to send spacecraft to planets. Well, that proof involved the cross product, and what if I don't understand the cross product completely? I've just memorized the definitions. I don't feel that I totally own the fact that that orbit of a planet is an ellipse. And I just feel that all the mental gymnastics and insight you gain from convincing yourselves or understanding why math and physics facts are true help you. Like, for instance, when I proved the Pythagorean Theorem, I used similar triangles and some techniques, and that just it got me exercised on using similar triangles, which are frequently used in math and physics to do things. When I proved the sum, we all learned the so-called sum and difference formulas for sine and cosine. I proved those the other day, and my proof, it's basically taken years for me to come up with those proofs, but because I just think about them from time to time. But what I learned from doing the proofs is that all I basically needed to do was know how to rotate a plane. Rotate the Cartesian coordinate system, the x and y axes. How can we do a rotation. If we have a point P, X, Y, and we rotate it through an angle theta, what is the image of that point P, X, Y? That's all I needed to do, you know, but it took me some time to realize that. So doing a proof helps you simplify. I mean, maybe I'll use that mental gymnastic, that mental framework for some other engineering problem or something. It also got me really good at rotations. Now I can, even when I'm walking down the street, I can rotate stuff for you. I can give you, I don't have to, and this illustrates why understanding is more important than memorizing. I'd never memorized a formula for rotating. I know they give you these like matrices for rotating. You know, that's not fun if you ask me, just to memorize. I enjoy the fact that I can just, you know, when I'm walking down the street, I can give you the results of rotating P, X, Y through an angle theta by just visualizing it. And I got that training in doing my proofs of the sum and difference formulas for sine and cosine. I'll rattle off the first one of those just so you know what I'm talking about. In other words, the sine of A plus B equals sine A cos B plus cos A sine B. Those are intimately related to rotating, and I discovered that. Also, proving that helped me prove the equivalence of the definitions of the dot product. You know, there are two definitions of the dot product floating around. I proved that those were equivalent basically using rotations. But I mean, trigonometry is just so fundamental to math and physics. It comes everywhere. I mean, electricity, waves, I'm guessing maybe string theory. So I just feel it's really important to understand the fundamentals. Let's just go through some things that, you know, we probably were asked to just memorize or accept on faith but not prove. I mean, one was the Pythagorean Theorem. So convince yourself that that's true. Watch my YouTube video on it, read a proof, try to do a proof or something, but, you know, try to understand why the Pythagorean Theorem is true. Another one is the square root of 2. Is that rational or irrational? Is the square root of 2 rational or irrational? You know, try to find the answer and prove that to yourself. I think I do a YouTube video on that one. Other things like the square root of 3, same thing, square root of 7. Pi, the number pi, is that rational or irrational? Well, you know, try to determine that. I don't like it when teachers just tell you the answer, because that's like spoiling the mystery. It's like spoiling the end of a mystery novel. I'd sort of like to revolutionize math and physics education worldwide, and I'd like to hear your comments. Does my philosophy of teaching math and physics, where students, you know, understand everything they do or see a proof of everything, is that going to slow them down too much? I don't know. You know, I wouldn't want to just tell my students whether the square root of 2 is rational or irrational without having them do or see a proof first. And again, it's like spoiling the end of a mystery. And a lot of those facts, you know, whether pi is rational or irrational, it's basically, if you ask me, it's sort of completely useless. The only fun about it is the mental exercise in proving whether it's rational or irrational. What are some other things that I think, you know, the quadratic formula. You may or may not have seen or done a proof of that, but you should see or do a proof of the quadratic formula, go through a proof of that. The polynomial long division, that's an algorithm. Oh, even more basic than that, just doing arithmetic by hand. There are algorithms we're taught, like how to add, let's say, a 3-digit number and a 5-digit number, how to add those. There was an algorithm we were taught. Do you understand why that algorithm works? By the same token, do you understand why the algorithm for subtracting multi-digit number works? Multi-digit numbers, or multiplying or dividing. You should understand those. And you might ask why, because we have calculators. Just because it gives you insight into the fundamental nature of mathematics. For example, when you get to pre-calculus, when you get to pre-calculus, you'll learn what's called polynomial long division. Well, if you understand why the algorithm works for long division for just regular integers, I guess we could call them numbers, positive integers. If you understand why the long division algorithm works for positive integers, then it's easier for you to understand the algorithm for polynomial long division. And I think many teachers will just ask you to memorize the algorithm for polynomial long division, but they should really ask you to understand why the algorithm works. They should either prove it to you, or have you read a proof, or have you come up with your own proof. I'm going to do a YouTube video on that, on proving why the algorithm works for polynomial long division. And then there's synthetic division, which is basically a shorthand for polynomial long division when the divisor is linear. Again, your teacher may have just presented that algorithm and said accept it on faith, but do not do that. Convince yourself why that algorithm works. Come up with your own proof, any old how, or read a proof, watch a proof on YouTube or something. I'm going to do a YouTube video on that. I mean, these things are key to math and key to physics, and I do think you need to understand them. Math and physics, you might say, well, it's really, really hard, but higher math and physics are super hard, you know? So it gives you good practice in doing hard math and thinking about hard things, these proofs, I think. I really am a big proponent of proving basically everything you learn when you learn it. There might be a few exceptions. I don't know. I might be hard-pressed to think of an exception. Maybe in the comments we can carry on this debate. Are there any exceptions to can you give me a good reason for a student to learn something in math or physics without seeing a proof of it or doing a proof? What could justify that? Anyway, I think I'll stop this video here.